I don't want to leave you out, Milos, but do you fancy doing some development?
At some point, yes. At the moment, I think I am sticking to the documentation, and also because most of this conversation goes above my head. But I'm learning, and I will be catching up soon.
My other meeting got cancelled, by the way. I have time if we need to be around.
Okay.
Awesome. Don't know if you guys want to stay on for a little bit more. We can actually start digging into the design of the monitor if you want.
I will need to disconnect in a couple of minutes, but
Yeah, okay.
I will carry on.
Paolo, what do you want to do? I'm happy to.
I can stay for more 15 minutes or so, and then in a few minutes I need to leave to pick up my kids. So, but I can stay for 10-15 minutes. It's fine for me.
Okay. So what I propose then is a code walkthrough of the monitor to show you.
Yeah, I think it will be nice. I don't know if you want to start now. I don't know what you have in mind.
It doesn't take that long. I could do a code walkthrough in about 15 minutes. How's that?
Yeah, that's fine. Let me just. Okay, probably I'll switch to my laptop in the meantime because I'm just on the phone. So get a better screen. 2 seconds.
Okay, cool. So, all right, Paolo will join on his laptop in a second, but in the meantime, I'll go through the code of the monitor.
Just a wee parenthesis. I just tested the things you were talking about, Derek. The boot nose flag.
Yeah.
And it seems that it doesn't replace the boot nodes in the configuration file. It just adds to them. Because I just put a crazy node in another blockchain, and it is still discovering the correct chain and syncing with 7-8 peers at once.
Perhaps we could ask parity for a flag in the Polkadot.binary that says force boot nodes or something like that. Because then we could do the test. Okay, thanks for that test, Milos. Right, let's get on to the code, and I've just increased the text size so that if you are watching the video later, it will be visible for you. I'm not going to go through all the imports. Basically, what I'll do is I'll just go through what the monitor does at startup, and then I'll go through all the configuration options, and then we can talk around what we want to do next. So there are four main classes. There's a data store class, and that, as you might have guessed, it's the connection, anything reading or writing from the database. And if you look in the data store class, you'll see it's using something called Sequelize. And Sequelize is an abstraction layer over a couple of SQL databases, which I find quite useful to use. I tried the Loki database, but it didn't work for me for our use case. So you'll see some legacy code or some prototyping code in here for that. Then there's the health checker class, and it's this class that I'm proposing that we're going to put into a separate worker. Then there's the message handler class. The message handler will receive gossip messages from other monitors. So if another monitor has done some checking, then when it's got its results, it will send those results out on the P2P network via the gossip protocol. And this message handler is listening for those messages. Just to remind you that we are not using REST or APIs directly from one server to another server. We are using boot nodes, just like the Polkadot chain is doing. And once the boot nodes connect, they tell you which other monitors are available. So you connect to all the other monitors at the same time, and then you communicate between the monitors by sending messages on a gossip protocol. Okay. And then that will go into the message handler. And then the last handler that we've got here is the HTTP handler, and that's the handler that is Parlock coming by desktop now. Okay, and that HTTP handler is the code that handles the front end, the user interface. There's a little bit of API in here, but not a lot. Okay, so those are the four main classes. We've got a data store, we've got the health checker, which is doing the work of the health check. We've got the message handler, which is sending and receiving messages using the gossip protocol. And we've got the HTTP handler, which is handling the user interface. Okay, and we just start off. And because we're using the libp2p, or we're using the P2P and gossip protocol, each participant in that network needs a peer ID. So if you've just cloned the repo, your monitor will not have a peer ID, and therefore you will not have this peer ID.json file. And if you don't have the peer ID.json file, it will create a new one. It will create a completely new random peer ID for you, and then it will write your peer ID to the peer ID.json file. And then the next time you restart the server, you'll have the same peer ID. Okay, so if you're actually looking at the monitor, you will see other monitors. Here's the list of other monitors, and they each have a unique peer ID. Okay, and the user interface works out which peer it's connected to. So this peer, which is running on my network, has got this peer ID. Okay, and that is Tom's monitor, and that's the development machine that isn't currently running. And in the country, I'll show you in the configuration files how you configure these things. Anyway, so that's what happens at startup. At startup, we work out what is our peer ID, and you set the peer ID. Okay. And then what we do is the HH, which is the HTTP handler, we tell the HTTP handler what is our peer ID, and we tell the health checker what is our peer ID. So all the components know who we are. Okay. Then we use the data store to update our own peer ID. So this upsert, if you're not familiar with database, it's to update if something exists. If something doesn't exist, it's to do an insert. So that's called an upsert. Okay. And we just create a monitor inside the database. I'll just show you what the database looks like. So there's my development database, and the development database has got 5 monitors in it. Okay, and that drives what we've got on this screen for monitors. You can see that this is the live version. It's not my development database. My development database would have 5 entries here. Okay, running through the code some more. Then what we've got is each monitor has got a local configuration, and I'll just jump to the local config. The way that the configuration is done is we have a config file, which you should not touch, because this config file has got the boot nodes in it. But what you can do is you can use config.local.js to overwrite certain things. So I'm going to run through the config quickly. Okay. The first thing that we see in config is what your gossip port is and what your RTC, but we're not using RTC at the moment, so that's not in use. I need to take that out. Don't want to do any breaking changes while I do the demo. Okay, so the config simply is what is the datetime format, and this datetime format will be used on the user interface and will also be used in the database. So if you have the US format, or if you have a different way of keeping numbers in your database, then you need to change this. SQLize, as I said, is the connection to the database. This is the config for making a database connection. I can't remember if I've got a password in here that I need to hide, but you would keep your own config to your own database, and you just overwrite it using the same key. Show that to you in a sec. Okay, I thought we would have to put something in here for peer ID so that we know who the other members are, because what we don't want is we don't necessarily want people running a copy of this and just spamming us with absolutely junk monitoring data. But this is not implemented yet, and the known peers is not implemented. And the peer ID actually now comes from that process, that startup process, which I showed you. So we could remove that. Known peers, not implemented. Okay, it will listen on the gossip port. And this is the same configuration that we've got. You know, when you spin up Polkadot, you have to do listen addresses, right? So this is just the listen addresses for that. That's the HTTP ports. You could change that to port 80 or 443. If you change it to 443, you would have to do an SSL with it. I've got all of this running through Nginx, which has got the SSL, so I just keep it on any port you like. This allowed topics is for the gossip protocol. In the gossip protocol, you can drop messages on the protocol, and those messages go against whatever topic you want. And what we're saying, this monitor will only listen for topics that are in this list. And there are 3 topics that are in the list. So you can see /IBP, that's not actually used. /IBP/services, that's if you want to advertise what services you've got to the other monitors. And /IBP/health check is if you want to advertise or send a message about a health check that you've done and you've got some results that you want to share. This update interval is number of seconds or number of milliseconds as to how often you want the health checks to run. So because this is my development machine, I'm running the health checks every 30 seconds. And we'll agree between us how often we want this to run. And then here you've got your Bootstrap peers. So that Bootstrap peer is my development machine, and this Bootstrap peer is the main live server that's running on the data center. And when this monitor, which is my development machine, starts up, it will connect to Bootstrap peers to try and find the other peers in the network. Okay, this is to say, do you want to run health checks on your own services? True or false? That I don't know if it's used. And then here you put a list of services. You don't do it in the config.js, but you do it in the config.local.js to say which services you want your peers to check. So if we've got 10 members, we will have 10 copies of the monitor running. And when I run my copy of the monitor, I'll advertise my services to 9 other peers, and those 9 peers will test me. And when they've tested me, they will gossip the results to everybody, and then we can do something with those results. That's the design of this monitor. Okay, I'll have a look at services in a sec. Then just a bit of, so for pruning, I've put here for my development machine, I've got, it will keep health checks for 90 days. And here you can see the pruning interval is every hour. So every hour it will delete the health checks that are older than 90 days, just to keep the database from growing infinitely. And I haven't really implemented this last piece here, which is, you know, what should the SLA be? So we've been talking about what checks we should be doing. And I think what we'll do is we'll take this out of the config and we'll put it into the worker or the workers that are doing the SLA checks. So that's those are all the configuration options that you can have in the monitor. When you go to local, right, you can see the local will overwrite the config. So whatever you've got in local will overwrite it. That's fine. So here you can see that my pruning is actually set to 12 hours, which is an overwrite of the 30 days or 90 days. Okay, and here you can see that I am advertising some services. I'm advertising the service URL, I'm advertising the name of that particular node, and I'm advertising what chain should be on that. Here you can see I put in some broken services, but also you could have these services. Basically, you just need a URL and a name, and that will allow us to run the check against it. Okay, so that's the config and the local config. Go back to the server now. That would make sense.
Derek, so this has to be completely permissioned, right?
When you say permissioned, anybody can run a copy. Anybody can run a copy of the monitor, and you don't have to. You don't have to be permissioned to join. I was talking about this earlier to say, should we have in the config, for example, should we have known peers? In other words, we will only accept health checks from known peers. Don't know. It seems like a good idea, but it's not implemented yet.
Okay, so yeah, I mean, otherwise, I think there's no security measures against false information. Yeah. So this is not a blockchain. So
no, we know it's not a blockchain, and as much as I'd like to jump in and create a solo chain, you know, with all the bells and whistles, we need to know if that's the route that we want to go down, because I think it's exponentially higher level of effort to run a blockchain to measure to do our SLA monitoring for us.
Right.
You might want to get there. I'd love to get there. I'd love to get there because it will be just, you know, it'll be like a showcase project. But I'm not sure about value. You know, is that where we need to spending our development budget right now?
Yeah, and in that case, you would need to think about off-chain workers and stuff like that. So I think that's like a completely different dimension. So I think we need to keep this permissioned.
Yeah.
Until we find a solution for the correctness of the data published.
Okay.
One question, Derek. At this stage, the monitoring solution can be monitoring parachains and system chains.
Yes.
Yes. Okay. So
yes.
the peer-to-peer is chain agnostic.
As long as that target answers our tests, it could be chain agnostics. So we could not test an Ethereum node, for example, because it won't do the RPC response. But you can see that I am already monitoring the parachains for mine and Tom's parachains. And if you just have a look at, I'll just have Kusama state mine. you can see it's already, so this has received these health checks via the gossip protocol. This server did not do the checks. The server received the checks from that server over there. And that's, why is that? Well, that's because it's a Metaspan service, and this monitor hasn't enabled check your own services. So check your own services is false. And that means we have received a health check from Tom's machine at 13:56, which is 25 minutes, 30 minutes ago.
Yep.
So, yeah, and I'm not sure how often that runs, but it looks like it should run more often. So something's not come through. We need to talk about gaps. We need to talk about all sorts of resilience items to see, you know, how much we want to build into this. But the health check data is fairly straightforward. It tells you the service that was tested. It tells you the monitor that did the health check, but it also tells you the peer ID that it found on that service. Okay, so in this case, it's Kusama State Mine. Okay, so that is not load balanced. But if you have a look at some of the services, for example, I know that this is load balanced. And you see from time to time, the load balancer will send you to a different peer. And when we discover a peer behind that load balancer, we mark the peer. We discover which peers we have found behind that service. At the moment, it's just information gathering. I'm not doing anything with this peer. But it might be, for example, here, if this was the other way around, if it was like really up there, 600 milliseconds or something, you might want to say, well, hang on a second, what produced that bad result? And therefore we'll be able to tell the node operator behind your load balancer, it was this particular peer that's always bad. Or, you know, if somebody's got like a network switch that's flapping or something. Okay. Okay, so we're now in the startup process of the node. In the startup process, you get your service IDs. Okay, and then for each service ID, what you do is you add your own services to the database. Fair enough. And then you add those service IDs to the monitor. What is that? And then you do some configuration for how to speak to other monitors using the gossip protocol. Itself, in other words, if you send a message out on the gossip protocol, if you're familiar with something like PubSub in what's that, Mosquito MQTT protocol or something like that, when you drop a message on a topic, you could sometimes read your own messages back, and you could get this echo relay infinite loop. So if you don't want that, you need to make sure that you don't read your own messages. Okay, so if I drop a message onto the gossip protocol, I don't want it coming straight back to me because I already have it. Right. So gossip incoming messages, that means if I receive an incoming message, I'll tell my peers that I got this message, and if they didn't get it, I'll give it to them. That's how the gossip protocol works. So that's what makes it really interesting. So it's a peer-to-peer network. And then there's some other information that we want to make sure is configured, and specifically we want signed messages. So that means even though it's permissionless at the moment, we don't have, we know that a message will actually come from the peer ID because it's signed. So if the monitor, which has a certain peer ID, sends a message on the gossip protocol, we can check that that monitor actually did send that message because the message will be signed. And and which topics are allowed on this gossip protocol. Remember, we had allowed topics in configuration, which is as 3 topics at the moment. Here we're creating the main server, which is called the libp2p server. We are feeding in a peer ID. Okay, these are the listen addresses, just like before. The transports, you could talk TCP, and also here we're talking WebRTC. I was playing with WebRTC so that you could connect from a browser directly to the monitor if that's a use case that we want, but it's not implemented it's not actually doing anything at the moment. The only thing that is doing anything is the TCP transport. You need this as part of the libp2p configuration. You need all of this. I've put the connection manager to auto dial, so if it finds a new peer, a new monitor that comes along, it will automatically dial that, continuously trying to keep the connection alive. And then there's some information about peer discovery, which is just how it is. Not an awful lot to say about that. And that's if it will relay messages, if it has a distributed hash table, and if it uses pub/sub. And it does use pub/sub because it uses the gossip configuration from above. And then you start the server. And the server will listen for messages. And when messages arrive, stuff will happen. So what we've done then is we update the monitor with multi-addresses. Sorry, the data store. We update the data store and we set multi-addresses. So if you look at monitor, one of the fields here is how can we reach you? And those are the addresses, just like you've seen them before. They're multi-addresses. This is where it gets interesting. I was playing with the distributed hash table just to see what's going on. These are just debug messages. But here you can see when we discover a peer, what is a peer? A peer is another monitor, right? So when we discover another peer, we will do in the message handler something called handle discovery. We'll come to the message handler in a second, okay? And in the pub/sub, if we get a message, we will use the message handler and we will do a handle message. Okay. This is just some testing to play with protocols to see what it does to handle so that we could ping each other. I was thinking we could create some sort of chat or some sort of protocol-based API, but not implemented. Okay, and what we do is now that all the message handling is listening correctly, we will publish our services. So here we've got message handler, publish services, and what are we doing? We're publishing our list of services and we pass in the libp2p instance. And we do that every interval. Every interval, we publish the services that we've got. So every 5 minutes, this monitor will send to the entire network the list of services that we want our peers to test. Okay. Also, every interval, we will run the health checks and publish the results. So every interval, we will take all the services that our peers have told us they've got, we will test them, and we'll publish the results on the gossip protocol. That's what this section does. It does, where is it? Await health checker.check and the service. And then you get a result. And if there's no error, you push the result onto a list of results. And at the end of all the health checks, what you do is you do a libp2p pub sub publish, and you publish to that topic, and you stringify the result. And as we've seen before, we get a result that looks like this. And it will arrive on the gossip protocol, and it will arrive like that. And we'll write it into the database with our own date and timestamp and our own ID. We need to talk about if the health checkers should have a UUID, unique, universally unique identifier, so that we could go back and say, well, I've got 10 health checks, but I understand that there are actually 12. Can you give me the missing ones? Don't know how we're going to deal with that. Okay, and that's how we gossip. That's how we gossip the health checks to our peers. And then we do the same if check own services is true. We check our own services, and then we publish to everybody else what the results of those are. So very early on, I was getting really good results because I was doing a check my own services, but there was no network latency. So I was getting something like 16 milliseconds turnaround, which is pretty good. Okay, and then every pruning interval, we'll do a data source pruning, so a data store pruning. That runs on an interval. And here you've got the HTTP handler that will listen for the front end. Any questions? Okay.
Looks great.
Cool.
So just one thing for the future. So when you publish your list of services for the other peers to monitor, and they do monitor and then gossip the results to the network, I think sometime we'll need to kind of normalize the results according to the locations of the monitor software and the monitored services. So, I mean, someone monitoring my services from the United States is going to get worse results compared to your machine, Derek, for instance.
Yeah.
So.
And I think what we'll find out is that we'll get a worst case scenario and a best case scenario. And if we could somehow link up to say, I don't know, and this is where we will get perhaps the data or some sort of API from what Milos is doing with the GeoDNS and that sort of stuff to say, well, if I'm in Sicily, right, what would my user experience be like? I would certainly not be routed to an RPC node in the US. I shouldn't be. I should be routed to something either in Turkey or in the UK, or something similar like that. We don't have that at the moment. At least I don't have that at the moment to say, well, which location, because we don't have a location in Sicily. So we can't simulate what the user experience would be like if they're on a 3G network in a holiday home in Sicily and they're trying to send funds to another wallet, right? We just don't know what experience will be like. So this is what we've got at the moment. And as you say, when you normalize it, what does that mean? Does it mean you reduce you cut off the longest one and you cut off the shortest one and you get some sort of, you get rid of the highs and the lows and you take the middle? I don't think that's fair, because the GeoDNS should give you the shortest one. So I think what we should do is we should collect the data, see what we got, and then start tuning how we do the monitoring. Okay, what I propose now to do.
Sorry, sorry to interrupt, but maybe we could include the location context in the results we display on the UI, so we know where that monitor is monitoring from.
Good point. So if you see in the health checks here, what you could see is you could see that this particular monitor got that result. It's the same monitor all the way down. Let's just see if there's another. Where's Tom's monitor coming in? Tom's monitor only runs every 5 minutes. Mine runs every minute. So Tom's monitor was testing against this service and got that result. And there isn't another monitor running against that service at the moment because there's only 2 real monitors. So we don't have comparables. If you went and had a look at this service, you'd be able to see a particular monitor getting a certain result, and it should be trivial to add some sort of graphical indication to say, well, this is US based, or it's UK based, or it's based in Turkey or Switzerland or whatever it is, to say, well, whether that's an acceptable result or not. You're right, we could do that. I don't know. Not yet.
Yeah, okay.
Okay, let's just run through the data store quickly. As I said before, it is running off of a library called Sequelize, which is a database abstraction layer that allows us to define objects like monitor, peer, service, health check, and log. It allows us to define relationships to say a peer has one service, for example, or a service has many peers. And then you could use that to say, get me a service and all of its peers, or get me a service and all of its health checks. And that's just the object relationship model, how allows you to not have to write SQL in your code, which is a lot of fun. Okay, so here is a method called sync, and that's called when the if you've got in your configuration initialize the DB. If you do that, it will wipe out your database. Okay, so you don't normally need to do that because there is a script here which is create data store. So you just type in node create data store.js and it will create an empty database for you. So you don't have to worry about using this initialized database in your config file. You can close the data store, you can log, and when you log to the data store, you provide a level. This is like debug, info, error, warning, etc. And the data that you want to log, and that just writes a new log record. If you want, this is the pruning. And that's it. That's all that the data store does. What the data store does is it exposes these objects that can be used throughout the code. So if you want to get a health check, you would do ds.healthcheck.get. Fairly straightforward. I'll show that to you in the next library. The next library that we've got is the actual health checker. And in the health checker, there's some boilerplate at the top. But basically what we do is we initialize the health checker with a copy of, or with an instance of the data store, connection to the data store. And then we can get service ID or handle provider error. This is what runs if the service is currently down that we're monitoring. And this, unfortunately, is a blocking activity, and it stops the front end from answering HTTP calls while an error is being handled. So that's why we need to take out the whole health check process from the user interface process. Okay, but what we really want is this function down here, which is called check. Okay, And check takes a list of services that need to be checked. And then for each service, what you do is you create an API provider based on the service URL. And then you try to trap some errors. And if that service provides an error, you handle it in the code above, which is the code to handle errors. Okay, then you connect to the provider. So this is really interesting. This connection can take 3 or 4 seconds. Just setting up the connection to the provider. It takes a while to make the connection, and then it takes a while to get the WebSocket open. When the WebSocket's open, you get provider is ready. And then what we do is we make an instance of the API, which is straightforward. We wait for the API to be ready, a couple of milliseconds later. And then we find out who we're connected to. Like I said before, we get the peer ID. Okay. And we write to the data store that we have found this peer ID against this service URL. Then we find out which chain we're connected to. We find out which chain type we're connected to. This is all data that goes into the health check. And then we use a library called performance. Okay. And the library called performance, we do a start. We take, I think that's in milliseconds. Then we do an API call, which is just API RPC system health. Okay, and then we do an end. And that's currently what we're using to measure the performance of a node. So it takes some time to establish the connection. It takes some time to open the WebSocket, but I'm not measuring that because I'm seeing that as network latency. Okay, and then once that WebSocket is open, then we make a very simple call, which is API RPC system health check or health. And then we take the performance, and then of course you get you get your timing. And that goes into what we call the result. The result is the monitor ID, the service URL, the peer ID. The source is that you've done a check. If I receive this via gossip, then the source would be gossip. Okay. And then the level, the level, and this is, whether it's a debug or just have a look here, you can see it drives this colorization as to whether it is over or under SLA. I think we'll take that out and we'll make this a lot more sophisticated with the SLA monitoring that we're going to do. And this is the actual record, what the monitor ID is, who did the monitoring, the service that they were monitoring, the chain type, health, etc., and some performance information. Then you disconnect. That's important because you don't want to flood that node with RPC connections. And then you update your own database. Okay, and then you send the results back to the database. So you update your own database with what this will do is you say that, okay, that service that we just tested, it's actually online. And again, we could make this more sophisticated to say, well, is it online, but is it syncing? Is it latest, block height? We could be a lot more sophisticated here with what we actually do against that service. And then we return the results. And of course, this health check result will then be gossiped out to all of our peers. Any questions on the health check? I think we've got a lot more. We've got our work cut out for us to do on the health check. Okay. Let's have a look then at the HTTP handler. This is an Express.js app. If you have not done Express before, then I guess this will be very new to you. Essentially, what you do is you set up the class with lots of local stuff, you know, what your date time format is going to be. Remember, we saw that in the config. And that drives things like, you know, what does that look like? It's used in the front end. And then you have certain routes, and the routes are what's up here. So /service, for example, is a route. So first of all, you get if the route is not API or metrics, right? We serve the index.html. So that's the default route. If the route is API/home, we will return with some information. If the route is API/service, we will return with service information. Okay, if the route is API/service/ and the service URL, we will return with information that looks like this. So what does it look like? This is API/service. You get all the information about the services. So that's the data that's driving this screen. All you have to do is you have to just put /API in front. You get all the data that is driving this screen. Yep.
Right.
Okay. And that's the same pattern that if you want to get all the monitors, you just go to monitor, just replace this with /API/monitor, and you get all the information about the monitors. You get a lot more than what's actually displayed. Okay. You get their services and all that sort of stuff. And if you go into one monitor, let's go into that one there, and you put you get all the data. So our API is already implemented. If anybody wanted to use the API, we could do that. Okay, and then you could do get API health check. And you could do get API health check with an ID. So if you went into the health checks and had a look at one, if you just got the you just get the raw. Interesting, you get that. You see the is syncing is false. We could use that. We already have this information. There. We already have that. Okay. Same for service URL, monitor ID, health check. And then I've implemented one check, sorry, not one check, one special API, which is if you're looking at a service, let's just say this one here, you could get the Prometheus information for it. And at the moment, the Prometheus information we've got is service error count. The service error count is incremented every time you try to make a connection, but the connection fails, or at least it should be. But we need to think about how we're going to do alerts. I was thinking that you know, services could monitor for this, and if that changes from 0 to 1 or 5 to 6, then that would be interesting. And you can get the IBP performance for 1 minute, for 10 minutes, and for 100 minutes, I think it is. And that's the average over those times. And that's the timestamp of the last. Milos, I think you're using this. No, not you. Somebody tuner, I think, or Math Crypto are using this to monitor some of their stuff. Okay, and then I was thinking about how to actually use this user interface. For example, if I'm on my own monitor, so this monitor, because there's a little tick there that indicates to me that I'm connected to this monitor. So if I'm on this monitor is currently advertising these services. But if I wanted to manage an outage, and if I want to bring, I don't know, 3 services down for an outage, how could I do that? Currently, what we're doing is we're chatting on Matrix to Milos to say, oh, take me out of the GeoDNS or whatever it is. And I was thinking one of the things we could do is we could log in with our Polkadot wallets, if you have a Kusama wallet or something like that. And you could send a signed message to the monitor to say, take this server down for 5 minutes, or take it out of the monitoring, not take it down, but take it out of the monitoring for 5 minutes, or take it out of GeoDNS for 5 minutes. But because I don't want to manage people's logins, what we could have in the config is we could have the management wallet address. And if you send a signed message from that particular wallet to this monitor, then we could enable that. And that would be a way of not logging in, but that would be a way of using your wallet to sign a message. The monitor would receive a signed message and know that it can only have come from your wallet. And in the config here, for example, we've got known peers, but we could have something like admin wallet, right? And if you've got the admin wallet address and you receive a signed message from the admin wallet, or in fact, it could be wallets, right? If you want to delegate, if you receive a signed message, then you could get either that particular monitor to do something, or you could get that monitor to send a message to all the other monitors to say, hey, this particular RPC is out of action for a while. And that I started to work on signing of messages. And it's not implemented, but it's one of the thoughts that I was having of how to use this blockchain style or substrate style of way of signing to have the authority. Yeah.
Nice.
Okay. So I mean, we're getting closer and closer to running a solo chain, I think, or to running a pair of threads or whatever you want to call them. But yeah, anyway. So, and then there are just some utility methods. I was originally writing all of the front end in a language called EJS. It's a templating language. So if you have a look here, for example, the monitors page was just an HTML snippet. but that required a round trip every time you clicked. So every time you click, you'd go and get another page. You'd go and get another page. So this is currently not used. I have already deprecated the use of EJS, and we're now running the whole front end from a Vue.js front end. And the Vue.js, if you go into this if you go into this directory and you do an npm run build, if you type that, if you build this website, it will build it into the static index.html. So, and it's this index.html that is served when you come to the website. Okay. What else do we have? So that's the static. That source is not used. That's just me testing stuff. That's the Prometheus exporter, which is just writing a bit of records to the screen. The message handler. The message handler listens to messages and sends messages to the gossip protocol. So here we've got a method which is handle discovery. That means when we've discovered another peer, and that peer will be another monitor, right? So what we're doing at the moment is we're literally just debugging to the console that we have found another peer. No big deal. Okay. Here we are handling the IBP ping protocol, which is just prototypes. It's not currently implemented. But what's most important and most interesting, I guess, is the handle message. And this will be a message that's arrived on the gossip protocol. And we do very little validation of it. We just check that it's a certain topic. And there should be, yeah, there's a case default. It's an unhandled topic. Okay, so at the moment, we receive messages of other monitors services on this topic, and we receive message from other monitors when they've done a health check on this topic. Okay, and what we do is we update our database for the service that was tested, the peer that was found, and the monitor that did the testing, and then we add this to our database.
Derek, I'm sorry, I got to shoot now for another call.
Okay, so we're pretty much done. I think that's, we're up to the end of 2 hours now. That's a long enough video anyway.
Okay.
Thanks, guys. Kutsal, let's touch base when you've got some time, because we want to start work on the next phase of the monitor, and I will similarly reach out to Paolo to start work on the alerting.
Yeah, so I'm planning to get it running over the weekend. I'll just let you know over Matrix, and yeah, hopefully I'll get it running, and then from there we can do some planning on issues, and I can start somewhere.
Fantastic.
Cool. Thanks a lot.
Okay. Thanks a lot, guys.
Thank you.
Thanks,
Very
Derek.
interesting. Cheers.
Yeah.
Bye.
Cheers.
Kutsal.
Bye.
Bye.
Bye, Miloš.